Welcome to In 5 Minutes.
So students, let's start with third sum, Laplace of e raised to minus t sin t whole divided by t. So again the case comes where you get different functions, different effects I can say. First shifting is the, you can see, division. So let's start with sum. If you remember students, I have suggested you whenever there will be a shifting effect, apply at the last. So now let's start with the sum. So you understood one thing, this is my original function, that is nothing but f of t, we can say. This is my effect, this is my effect. Now first we need to find Laplace of sin t, which is very easy. This comes 1 divided by s square plus 1. So we can say this is nothing but your phi of s. So now Laplace of sin t divided by t. So I'll be putting an effect of t first in initial and then shifting. So t gives me s to infinity phi of s. I am keeping it directly divided by s square plus 1 ds. Students, you know that integration of 1 upon x square plus a square dx is equal to 1 upon a tan inverse of x by a plus c. So we can use the same formula here where you are having a square equal to 1. So I can say 1 divided by 1 tan inverse of s by 1, where your limits are s to infinity, which comes, when you put infinity, it comes tan inverse infinity minus, put s, it comes tan inverse s, where finally I can say tan inverse infinity is pi by 2 minus tan inverse s as it is, which I can write as cot inverse s. Now still we are remaining for applying effect of first shifting, which gives me Laplace of e raised to minus t sin t divided by t. That is nothing but I'll be getting effect s plus 1 due to e raised to minus t. Then final my answer comes, which is equal to cot inverse. In the place of s, I'll be writing s plus 1. That's it. Now we'll solve one more sum, which will be my last sum for this effect. This will be my fourth sum. I need to find Laplace of sin square t divided by t square. So here you can see that there is a t square. That means there is t into t effect. That means two integrations we need. So let's start. First we need to find Laplace of sin square t, which is nothing but Laplace of 1 minus cos 2t divided by 2, which comes 1 by 2. Laplace of 1 is 1 by s minus Laplace of cos 2t is s upon s square plus 4. Now let's apply effect of t square. Before that, I'll be just applying effect of single t, and then further let's apply one more t, which comes here s to infinity phi of s ds. So this is my phi of s. Now I'll be writing as s to infinity, that will be 1 by 2 1 by s minus s divided by s square plus 4 ds, which gives me 1 by 2 integration of 1 upon s is log s minus, here we need to do adjustment of 2 and 2 as we did it previously in the same way. So I can say here 1 by 2 log of s square plus 4, which gives me s to infinity. The next step I'll be getting 1 by 2 outside, it comes 1 by 4 here, log of 2 multiplies 2 goes in raised to of s, that comes s square minus log of s square plus 4 s to infinity. This gives me 1 by 4 log of s square divided by s square plus 4 s to infinity. Now directly I can write as 1 by 4 log a by b s to infinity is log b by a, so s square plus 4 divided by s square. So that's my answer when you apply effect of t. We need to apply one more effect of t. So this will be again acting as phi of s. Let's say this is phi 1 and this is phi 2. So I say here phi 1.